just missed that excitement there. Let's see. Where am I at? 40, did I 41, right? 47, 49, okay. And then 50. Shaboop. Cool, all right. Okay. So now I've got my data in order. It's going to be a little easier to do what we have to do. I don't know if you guys realize, how did we figure out 10% were in here? I counted how many grades were between these two, right? So when it's in order, it's going to be easier for you to do that. Now, let me take you down the path of why this math we're going to do makes sense. Some of you guys might not immediately understand what I'm doing, but I'm used to that. I'm a math teacher. Let's say, for some weird-ass reason, I want to put wood panels on this wall, right? I love the 70s. I want to bring it back. So, if I want to use 5 wood panels, just because I love the number 5, all right? So don't question me. I love the number 5. How do I figure out how wide each one has to be so that I cover that whole wall? What I have to first figure out how long it is, right? From there to there, how long do I have to cover? And then what would I do with that length? Divided by 5, because I want to use 5 rectangular shaped panels, right? That's kind of and then I can figure out, and then when I do that division, it's going to tell me how wide they have to be. So that's 20 feet long, divided by 5 panels. They each have to be 4 feet long, right? All right, let me stop there. Is that decent? That's a physical interpretation of what we're about to do. It's the same idea, actually. How far do I have to cover in terms of data? From what to what? 7? 50. So how wide is that? Yeah, so 50 minus 7. 43. And then I'm going to divide by how many rectangles I want to use. And we normally use between, this is important, we normally use between 5 and 10. The smaller the sample is, the closer to 5 classes you want to use. So for this tiny little sample, I would use 5 or 6. Let's use 5. Is that cool? All right. So sometimes I'll tell you how many classes to use, and some, like on a quiz, I normally say use this many classes. But on a test, then I'm just going to say pick some classes, right? So if you use 4 classes, oh, that's no good. You're going to lose some points. So if I use 5 classes. So here's what we just did to figure out the class width. Let me put the formula down. What's 43 divided by 5? 8.6. Real quick way to divide by 5 is you double this and then move the decimal back 1. Right? Because you double it, make it divided by 10. So it moves the decimal. So 8.6, you always round that up no matter what. If it's a decimal, you round it up to the next number. So if it would have been 8.1, I would have rounded it up to 9. Why does that make sense? Because I want to cover everybody. I don't care if I over-cover everybody. I just want to make sure that I cover all my data. So the formula we just used for class width is high minus low. Please make that. That makes sense, right? The highest data point minus the lowest. That's the range of data that I have to cover, divided by the number of classes I want to use. Sure. That's how you figure out how wide each bar has to be. All right. Now, continue to stay with me. I'm going to show you 2 different ways to set this up. One way is the way that most books, not all, set it up, which is really silly. And then I'll show you a second way that I like. Myself, I like to do it better that way. But you don't have to do it that way if you don't want to. You can do it the way the book does it. All right? I'm going to show you both ways. We know our end result, we want it to look like this. So, my first class should start where? I mean, you could start it at 5 or 0, but normally you try to start it right at the first data point. Okay? So 7 to something. Now let me make sure you guys understand why the textbook method is the way it is. Where would the next class have to start so that my width is 9? 16. Is that cool? Now, if I also put a 16 here, where the hell would 16 go? There's 2 places, so this is going to be 1 less. All right, does everybody see that? So you're not going to see the width between these 2. you'll see the width this way. So basically what I say is you put 7, and then you add the width, add the width, add the width, and then you do this, and then you put this down one and add the width, add the width, add the width. So this will be plus, what was it, 9, right?
25.
Plus 9, 25 plus 9,
34.
plus 9. Okay, that's 5 of them, right? And then it's going to be 1 less than this, 1 less than that, 1 less than that. Ooh, get in there. And then add 9. So that's 9, 9, 9, 9. Just make sure at the end that they really are as wide as you wanted them to be. Let me stop there for a second. These are what's called class limits. So now you just count. Now you just start counting. How many numbers are from... Don't say 8, 8, 8, 8. Do you see why somebody would think that? That's not what we're doing. How many of the data points fall between 7 and 15?
1.
2. Right? 7 and 11. Is that cool? So there's 2 data points. So this is going to be what we call our frequency. What is the frequency? So that's how frequently data showed up in each class. So how frequently here? Twice. How about 16 to 24? 1, 2, 3, 4, right? Does everybody see what's happening? Let me know if not. So from 7 to 15, how many data points are between 7 and 15? 7 is, and 11 is. Don't forget, that's 11, right? 7 and 11. There's 2 things. Bam. 2 things that fall in there. How many numbers fall between 16 and 24? 1, 2, 3, 4. 16, 17, 18, and 22. Do you guys see that? I like it. So it's not that huge of a deal, but it's different. So I understand if you're not really, what the hell are we doing? That's all we're doing. Counting how many data points fall in each. That's how they distribute amongst all those classes. So 4. 25 to 33.
5.
1, 2, 3, 4, 5. I like it. 34 to 42. 1. And then 43 to 51.
3.
Yeah, 1, 2, 3. How many data points were there? 15. So what this better add up to be?
15.
Okay, so let's see. 6, 11, 12, 15. Thank God. All right. It so sucks when that number comes out to be 14. You're like, which, especially if it comes out to be 79, it's supposed to be 80. You know, what the hell? Oh shit. But that's the nature of data analysis, right? That's those crazy ass work from home and make a lot of money per week. Well, it's data entry. You're going slowly insane. That's why, yeah, don't do that. That's why you will go insane. The next level of this, how do I say this? Whole numbers of things make it difficult to compare. To make it easier to compare, I want to calculate percentages. And that's what we call relative frequency. We call it relative frequency because it's relative to the total amount. There's 2 in there out of 15. So what's that about? Like 13% off. Somebody, you guys have calculators in that class? Yes? I love how somebody on calculator. What? I've got to show off a little bit. All right, 13% roughly. So 4 divided by 15 would be roughly 26%. All right, we'll go with it. Is everybody cool what's happening now? We're just calculating percentages. Percentages is part divided by whole.
And then do you want them to add up to 100?
Yeah, either 100 or close to it because we're rounding now, right? So it might come out to 99 or 101. But if it comes out to 95, that's too far away. You left somebody out. So this is about 26, is that right?
Yeah.
Yeah. So truly round that, right?
What do you want?
What's that? 5 out of 15 is 33%, of course, right? It's 1/3, 0.3333. And then 1 out of 15 Is that about 7%? 6%? 6%? I'm trusting you guys. 3 out of 15. Ooh, that's 20%. Yay. So how's that come out? Let's see. 39, 72, 78, 98. That's kind of rough. You sure that none of these were rounded the wrong way? I'll take your word for it. Huh?
I was asking you, do you round up?
You round, period. So which number do you think might be off? This one? 40 by 15 is 26 point something?
26.6.
Ah, see, so this is 27. Then that becomes the more acceptable 99, right? Okay. To truly round those numbers. Why am I okay with rounding it to a whole number? Because we're going to graph this by hand. 6 and 6.1 look the same when I graph it by hand. So there's no point to it.
What is?
Oh, sorry. This is relative frequency. What we also call percentages, but what officially is called relative frequency. All right, so, oh good, I can make this diagram and stick to my promise to let us out early. So here's the problem with I like how you guys are double checking it. Did you tell the truth? Here's the problem with the book method for these classes. If I draw the histogram 7 to 15 and then 16, isn't there going to be a gap here? Do you see the problem?
Yeah.
Okay, so the way it's taken care of, I don't want to talk bad about it because it is an acceptable way to do it. And I don't know why most textbooks do it this way when there's a much better way to do it. I'll stop. Is to use what's called, so like, this is the limit of me. This is where Jeff stops and the air starts, right? Like here, this is my limit. But don't I have a boundary where if you come too close, I'm like, whoa, step back. I don't know you that well, right? So I have limits and I have boundaries, right? If you're here, you're okay. If you're here, I'm like, who the hell are you? What's going on? So I make class boundaries. I go up and down by a half. Because now, what's this going to be? Go down by a half? See how these match up? There won't be any gaps. You just do that for every single one. 24.5. All the way down. Right? I like it. Now, let me show you the other way to have done these classes from the beginning. And you don't have to do it this other way if you don't want to. You can see why that way kind of sucks. But if you're not comfortable with inequalities, you might not like this other way. So I would set it up like this. 7 less or equal to x less than 16. 16 less or equal to x less than 25. Do you see how I can see 9 now? Where's 16? Now I see somebody's already opted out, which you're fine. You're fine. I'm not going to take it personal. I cry a little bit. But see how there's no freaking ambiguity at all. Where's 16 go? Which one's allowed to equal 16? The second one. Careful. This is less than 16. I like it. So some of you guys might like this way. If nobody does, I'm not going to take it personal. It's okay. Our heart aches a little bit, but I understand. You're like, I did algebra. I did my time. Leave me alone. Yes?
So it's okay that there's gaps if we use the textbook way?
There won't be any gaps because you have to do this.
Okay.
Up and down by a half, so that forces that end to match up with that. There won't be any gaps. The only gap would be if there's 0 somewhere, then it really means something.
And when we're writing that out, you want us to just put like a little 6.5 and like.
All right, you ready?
Right now.
So if you do it the book way, number one, you got to remember to do this weird shit. And I can't help but talk bad about it because I wish they wouldn't do that. But I understand that people don't like this. I understand. So if I did it the book way, I'd have to use the boundary, 6.5 to 15.5. If I did it this way, I could just put 7, 16. Oh, that looks much better, right? But if you don't want to, it's okay. Some of you guys might. If you don't want to, you don't have to. You can pick either way. I'm not going to give bonus points to my special students. Nobody gives a shit. I don't care. Whichever way makes more sense. I don't care. Okay. So let me just finish this one out. That would be nice. You guys can do that. Blah, 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 blah. 6.5, 15.5. Now you just keep adding 9. Right? Because that's how wide it is. 24.5. 33.5. I got to get you out of there. Go away. Where am I at? 42.5 and then 51.5. Now how tall, if I want to use the percentages, I want to do the relative frequency. How tall, how far do I have to get up there?
30.
Yeah, 33 is the highest one, right? So now you can figure out your scale. Your scale has got to be consistent. So don't write this. What if I do this? 15, 25. Is that all right? 5, 15, 25. That seems great. That ain't right. How wide is this? 5. 10. Oh shit, no. See, so you got to have a consistent scale, right? You can wait, whatever scale makes sense to you. Please don't do ones when you got to go to 33. I've had people do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All working, no play. Make check. No. So I want to get up to 33. So maybe go up to 35. Maybe we can do by 5s. So I'll do by 5, 10, 15, 20, 25, 30, 35. Okay, good. There. You just have to make sure that it includes all the percentages you have to graph. And I just make bars as tall as they need to be. So let this first foray into data, descriptive data analysis be simple. Let it be nice. This bar is going to be how tall? 13. So I'll just kind of put it, then it'll be perfect. It's about in the middle of those two, right? Then it has to go up to 27. Again, it's going to be in the middle of 25 and 30. 33, my tallest one, going to be in the middle of 30 and 35. And then 6, it's going to be about right there. And then 20, where's 20? There it is. So what do I label this? So this is going to be relative frequency. I could have asked you to make a frequency distribution, and then you would have used these numbers, right? That's all. What did I give us? What was it? What was the idea here? The grades on a 50-point quiz. All right. So it looks like a lot of people got in this region, right? And not as many people got the higher grades. Exactly. All right, so that's from section 2.2. It's all about histograms and so forth. So we're doing really good. I mean, that's plenty. We can head out early. Any questions from that stuff? Okay, so if you need to see me, come with me to my office if you need ad codes or whatever else. Okay. All right, we're going to go back.